Docker, CentOS, sorry, boot to Docker, CoreOS, and Project Atomic. I haven't heard about lots of people actually using boot to Docker in production workloads. It's really great for the local laptop as a dev platform because that was kind of the goal of the project. It can work on servers as well, but it's not common. In that case, people tend to look at CoreOS and Project Atomic when they want to do greenfield deployment. They have no legacy, no nothing, and they want to try something which is really made for containers. It's a great choice if you are ready to go bleeding edge and update early, update often. You can also, I mean, at Docker, our production platform is using Ubuntu 14.04. So. And we are extremely happy with it.
The second question I have is that you said you only support Intel 64, and you listed a couple of things that works but don't support. Are you planning to support any of them? If so, what is the top priority?
Are we planning to support architectures other than Intel 64? Yes. I don't have a specific date to tell you, but we definitely want to support that. And we already have tons of people in the community who worked on actually building the binaries and building images and making sure that everything works. So it's a kind of separate universe in the way that officially we pretend that this doesn't exist. But if you go into the Docker repository on GitHub, you will see all the things you need to build on those other platforms, and you will find links pointing to base images or explaining how to build them for other architectures. So we really want to make that happen. The only difficulty is to make the registry aware of the architecture of images, and then have creative ways to do kind of cross-arch builds. Because one of the points of debate is the Docker file. There is nothing architecture specific about it. The Docker file that I used, I could use it to build on anywhere, as long as I have a base Ubuntu image and I'm doing apt-get installs. So I need some package repositories with my architecture. But if I have that, then my Docker file is totally portable. So then we could do things where when you push your code and you have an automatic build, we automatically build for a number of architectures. But then things get a little bit more complicated. So we're still kind of evaluating those options. It's not like a high priority on the business side of things, but it's something that we want to make happen. And if people want to take over that and make it happen, we'll be extremely happy to help them to contribute it. Yeah.
It looks like each Docker container gets its own slash on the disk. The disk partition. What's the way to access the disk for a given container and do security scans or something like that?
So each container gets its own file system, and so how can I get into the file system, for instance, to do a security audit or something like that? There are multiple ways. In the general sense, there is something called Docker exec that lets you drop into a container, so you get a shell inside that container and you can do whatever you want. But there is an interesting way to deal with all the things that we typically do with SSH, basically, can be done differently. And in the beginning, it was kind of complicated to think about it. How am I doing to check logs of that application if I can't get a shell in that container? How am I going to do like a TCP dump to inspect network traffic? How am I going to do a security scan? And then after thinking for a very long time, we found some interesting ideas. For instance, for logs, we can put the logs on a separate directory that is called a volume, which is conceptually like a remote disk or like a USB stick, if you will, that you can move between containers. And so basically, and it can be shared as well. So when you want to check your logs, you actually start a completely different container, and then you go check your logs without impacting the other container. And that has some interesting advantages because, for instance, if you do a grep or whatever that ends up using tons of memory, you're not stealing precious memory from the application container, for instance. Specifically for security, we had discussions recently with people from Yandex in Moscow and Symantec recently run here, and there were some really interesting ideas coming out of that, where basically if you use the immutable infrastructure approach, so where your server image, your container is read-only, when you want to do upgrades, you bake a new image and you deploy that, then it means that to do your security audit, if you can force that to technically be read-only, then you know exactly what's inside, because it will be exactly the container image. So instead of going inside the container and looking at the files, you start a new container and you inspect that container separately. So you can do your security audit completely separately from the production platform. The same way if you want to run like an SS scan or something like that, you can just start a copy of the container and run your scan on that instead of on the real thing. Of course, to do that, you need to enforce immutability read-only on the containers, which is not entirely straightforward yet, but it's a very interesting prospect.
How do you debug containers?
How do we?
Debug if it crashes?
How do we debug containers if they crash? I don't know. How do you debug normal applications?
Debugging using means traditional tools we use, GDB and all
Yeah,
log files
all the
code dump
things.
is created.
Yeah, all the things that we typically use with normal applications outside of containers will work as well inside of containers. So you can strace, so you can always use this Docker exec thing to get a shell, but you can also do stuff like strace from outside. You can GDB from outside, but it's a little bit tricky. You can do TCP dump and ngrep and network analysis from outside as well. So basically all the things that we were already doing can still work, and in some scenarios we can even do them in, let's say, interesting and creative ways.
What is the difference between the on-premise Docker Hub, which is a quick offering, and the registry that's open source?
Right, so what's the difference between the Docker Hub Enterprise on-prem and the open source registry? So that's basically because the Docker Hub is multiple things bundled together. There is a registry to store images, but there is also the build system that can respond to webhooks to fetch code and do builds and store the results. And there is also user authentication, ACLs, team management, and all those features. When you get the registry, you just get the registry. So it's just like something where you can push and pull containers, but there is no authentication, no notion of user, no nothing. You can add that on top of it yourself very easily. But the default registry is a very simple product. That's the key difference. In one case, you just have basically a kind of an anonymous file storage thing. In the other, it's a full-fledged thing with integration with existing users and ACL and authentication. Yeah.
So the question is, so where is the Docker networking stage at this point? State of affairs there. I see some projects are on Weave and Rudder. What's the current state at this point?
So what is the state of the union for Docker networking? That's an excellent question. There were recently a proposal from a very new and young company, SocketPlane, who basically made a kind of big recap about, okay, this is state of containers, this is what we can do, and then we are currently debating a number of proposals. So I probably should not bet on any outcome in the sense that there are lots of discussions happening right now. We really want to make sure that the network stack will be, instead of being like the current one, which probably works for maybe 50% of the people, we want to have something that works for 90 to 99% of the people. Because today, if you're not happy with the way the network stack works, you can still basically open everything and put on your own stuff, and that works, but it's kind of non-standard, and then you feel like your hands are dirty or something. So we want to have something which will work for the vast majority of people and won't require them to change their existing Docker setup.
So can a container be assigned an IP address?
Can we assign an IP address to a container? Kind of. There are multiple ways to do that. The general answer, when people ask that very often, it's because there are other ways to do what they want. For instance, if you are talking about private internal IP addresses, because you say, well, I want to start my database and then my web server, and I need to set up the IP address of the database inside the web server, then the answer is no, don't do that. There is something called links, which will automatically set up names for your containers. And in that case, when you will be inside your web server, you will be able to just do a DNS resolution for DB, and that will resolve to the IP address of the database. So
if these two containers come different hosts, then I still need an IP address.
yeah, if they are on different hosts, that kind of loops back to the previous question about state of networking in Docker, which is that currently there is no out-of-the-box, it just works and it's a great solution for that. There are multiple approaches. There are projects like Weave and Flannel that tend to build a flat network on top of your containers, regardless of where they are located. Some people are also looking at IPv6 because once you have IPv6, you just have a flat network as well, and everything is nice. So those are some of the solutions. Some other people look at using service discovery, where you don't really care about the IP address of the container. You just say, okay, that container is exposing the API service. It's on that host, that port. I'm putting that into Zookeeper, etcd, console, and then when I need to connect to it, I will look it up, connect, and do my things.
Right, okay. How do I assign IP address if I need to create a container?
How do I assign IP address, like public-facing IP addresses? There are multiple ways to do it. If you have some hardware that supports SRIOV, which means like breaking down a physical interface into multiple virtual interfaces, then you can do that, assign the IP address to one of the virtual functions, one of those sub-interfaces, and then you can move that interface, give it kind of to a container. You could also do that with the physical IP address, but generally we don't have that many physical interfaces. You can also assign multiple IP addresses to your machine, and then when you start the containers, in my example, I just told to Docker, start that, and it gave me a port like 49153, but I can also force the port and the IP address. So I can tell to Docker, expose that web server on that IP address and that port. Yeah.
So with microservices that rely on each other, it's a lot of times if there's an affinity, you want to put them on the same machine so they don't go out on the network and connect. Can we do that, something like that with Docker containers? I mean,
so if there is some affinity between microservices, generally we want to bundle them together to optimize for latency. How do we do that with containers? So it's a rather complicated answer in some way, because it really depends on what we use to scale out, deploy, and orchestrate our containers. There is, for instance, something called Maestro NG, which looks a little bit like Fig, except it's multi-host. So you have a big image file, and you say, I have this and this and this container, and they are here and here and here. So you pick exactly where the containers will be deployed, so no problem. Now, if you're using, for instance, Kubernetes that we evoked briefly earlier, Kubernetes has the notion of pods. A pod is a group of containers that are meant to be together. And so in that case, the members of the pod will always be deployed together, and they will share the same IP address, the same network namespace. With Mesos, I'm not 100% sure, but with the upcoming Docker scheduling mechanisms, we are already thinking about this notion of affinity, like those containers must be together for latency, or those containers must not be together for availability, for instance.
Continuation of the question about debugging containers. So what do you mean by crashing of a container? As I understand it, container, there is no associated process which represents the container, right? So what is the meaning of crashing of container?
So what does it mean, a crash of a container? It's the same thing as a crash of a Linux process. So the container itself, there is no extra process because of the container. When you say, oh, I'm starting a container, it doesn't mean I have a magic process containing the container. It just means I'm starting Nginx in my little example, and it just means that there is, the container is Nginx, or Nginx is the container if you want. The thing that makes it a container is that it has a bunch of tags and labels and everything that say this process belongs to a specific set of namespaces and control groups, and together they make a container. So what does it mean when I say, oh, my container has crashed? What I really mean is the process inside the container has crashed, and there is one little scenario where things will be different from on a normal machine. Do you know what happens, like on a Unix machine, when PID number 1 goes away? Well, the machine crashes immediately. Instantly, the kernel says, well, PID 1 is dead, so I'm going home. And the whole machine crashes instantly. In a container, it's the same thing. If the first PID that you run in your container goes away, then the whole container goes away with it. On the Unix machine, this is not of a big deal because PID 1 is in it, and so it's solid. It's something that hasn't changed a lot for the last 45-ish years. It just starts processes and keep them running, and that's it. So that's solid code. Well, except if you replace that with systemd, but otherwise, that's robust code. In a container, now we have a new possibility to directly run Nginx or Apache or MySQL or whatever we want, and that might crash. And then the whole container goes away. It's generally not a problem, because if your MySQL main process dies, even if there is like a MySQL sub-process remaining, it's not extremely useful, and actually it's a rather good thing that this process gets moved out. But in some scenarios, it could bite you. If you start multiple processes in your container and the leader dies, then everything goes away with it. But it's pretty uncommon.
Does it automatically happen if one process dies and all of its children also die?
If the first process, PID1, dies, then the whole container is like sick kills with it.
Okay, and the process one's equivalent is the process I'm starting in the container?
And the process 1 that we're talking about is the one that started the container in the first place, yes. When I do docker run ubuntu bash, then that specific bash is the first one. Which, by the way, means that if I do docker run debian bash, and then I do, once I am inside my container, I do /etc/init.d/mysql start, I say, oh great, I have started my SQL server, I can exit my shell. When you exit that shell, it was the first process in the container, PID1, it goes away, and your MySQL server goes away with it. Yeah.
I was understanding that Docker is the elite process for the container.
That Docker was?
The PID1.
Oh, so you thought that Docker was PID1 in the container? Not quite. We are thinking about moving to a state where there would be something like that, but to show you basically when I was disconnected, timeout. Okay, what I wanted to show is the process tree, and to show that you have the Docker process, and under it we would have seen directly Nginx, Mesos something, Vault whatever, and Redis. There was no extra intermediary Docker process. However, we are thinking about that to handle upgrading the Docker daemon, because today when you upgrade the Docker daemon, you kind of lose the connection between Docker and its containers, and it's extremely difficult to reattach. So if we have a little proxy or broker or intermediary container, then it becomes much easier, because this little thing can say, oh, Docker daemon went away. That's fine, I'm going to buffer logs and things, and whenever the Docker daemon goes back, we're going to reconnect to it, and everything will be fine.
So like every container will have a parent Docker process rather than Docker daemon being a parent.
I'm not sure I had heard it entirely, but I think it's the case.
Are you saying that if the Docker daemon dies, then nothing happens to the rest of the containers?
So today, when the Docker daemon dies, normally all the containers keep running. However, there was, I don't know exactly what's the current state of this, but at some point when the Docker daemon would start, it would say, oh, I'm going to kill all the containers.
Okay, that's a special case.
I think it might still be happening, but yeah.
So the trick is, if the daemon dies, don't restart it. until you're done with your containers?
Yeah, if the daemon crashes, that's a good point. Yeah, yeah, we can talk about that offline if you want. Yeah. Any other question? Well, thanks. Okay.
So in your example, you had apt-get update in your Docker file. If you run that today versus yesterday, you might have different binaries.
Absolutely. In my example, I'm installing packages. So if I run that at different times, or even as I said, if I have some servers in different geographic zones and they just happen to use different package mirrors, I could have different results. Exactly. Which is why when we talk about shipping the containers, we ship those images. Which is why it kind of sucks when you do the demo and it downloads like 200 megs of stuff to run the container, and you're like, I'm going to make a little dance when it downloads. But that's the only way to make sure that we have like bit for bit exactly what we want. If I do my build today, I push that to the registry, I go back in 2 or 3 weeks, 5 years, I will have the same thing in the same state. Of course, if I rebuild, I might get something different. So there are ways when you really want to achieve repeatable builds. There are ways to do that anyway by pinning versions. So you say, I want to apt-get install Nginx that exact version, or that typically that's done for dependencies inside your code. So you say, I'm in Python, I'm going to install Django version 1.6 point something. I'm in Node.js, I want to install Express, I want Express that exact version. So that if you rebuild later, it will be tied to that version and not the latest version, which might be completely different.
So there's a follow-up question on that. So sometime back you showed, you built a Docker, you changed a small thing, you built again, and some steps didn't happen because Docker knew that it's already done. And apt-get, it can't know that whether it should do
What
it.
happens if I'm relying on something outside, like apt-get update, and so the world around me has changed, and I'm not aware of it, so Docker just goes through again. Like there is a new update of libSSL, and I'm not getting it because Docker thinks it's not necessary because it's in cache. So there are multiple ways to work around that. Well, there is a Docker build -- no cache that helps. Docker doesn't have, and probably will never have, a way to guess that automatically, because it has to kind of look at the command line and say, apt-get update, oh yeah, I know. I only have to run that when the upstream Debian mirrors have changed. So it's kind of not realistic to expect Docker to do that. But there are some combinations. For instance, if you, my example, I was building on top of Ubuntu 14.04. If my base Ubuntu 14.04 is upgraded, that will automatically invalidate my cache, because the cache works on the underlying image, not just the fact that it's Ubuntu 14.04. So if there is a new Ubuntu 14.04, the next time I build, it will rebuild everything on top of that image.
Sorry, one more question. In the beginning, somebody mentioned about the Cloud Foundry and some overlap with Docker containers there, right? So I think I had this confusion of they have the garden containers in Cloud Foundry. Are they same as Docker containers, or is it a fork of Docker, or what is the deal? But I don't know, there is some confusion on.
So what's the difference between Docker containers and the walled garden containers of Cloud Foundry?
Not the warden ones.
Oh, not the warden one? Oh, the new ones? So
they say it is Docker compatible.
The short answer is, I have no idea. The long answer is that after talking with people from Active State, which is building on top of Cloud Foundry, with well, people from Pivotal, so the upstream Cloud Foundry, people from IBM with Bluemix, which is also based on Cloud Foundry, I had the impression that every, I would say, fork or every implementation, I don't know the proper word here, of Cloud Foundry, had like removed Warden to put Docker instead. And at some point, Pivotal said, well, okay, we get the message, we're going to get rid of Warden and put something based on Docker instead. I have no idea of the reasons motivating that in the ecosystem and everything, because I can only talk about Cloud Foundry while waving my arms. But yeah, I think it's going to a point where Docker containers will be used as a kind of exchange format and standardization point.
So Docker is not, as a project, not fork.
So
Docker is
Docker,
still one project. There is no fork on it.
no, there is no fork of Docker as far as I know. Okay, thanks a lot.
Thank you, Jerome. So everyone, before we break for the night, just wanted to say that this is probably going to be the last meetup for the year. So, but we're looking for topics for January and follow-ups there. Also, quickly wanted to give a shout out to Ken Owens, who's over there. He's the CTO of Cisco Cloud Services, and he's the guy who's been sponsoring the room, the food, and the meetups for us. So thank you, Ken.